You guys, I wanted to show you a video on how to solve word problems, or just at least get you some practice on how to solve word problems. All word problems will not be the same. However, if you maybe see a few, then you may be able to dissect a word problem on your own. So here are a couple examples. For instance, this first example here: the cube of a number equals 9 times the same number. Find a number. So there's a few things in here that's important. Cube, for example, of a number. When we don't know what the number is, then what do we represent the unknown number? We represent an unknown by a variable, and we usually use the variable x, even though it can be any letter. Alright, equals, we know what equals is 9 times the same number. What was the same number? It was the x that we don't quite know yet. So let's pull up this whiteboard here. So again, the cube of a number. How would you represent the cube of a number? You could say x cubed. And of course, equals would just be equals. 9 times that number. The number was x. We don't know what it is yet. But 9 times that number would just be 9x, right? Because when a number is right beside that variable, that is multiplication. Now we have an equation. So we're solving an equation. Now, this is when you follow the steps that were given to you in a previous video on solving equations using factoring. So the first step was to get everything on one side, if you recall. Get everything on one side. So what I'm going to do, since the leading coefficient is 1 here, can't see it, but it's understood as 1, is already positive, I'm just going to subtract with 0 now. Do you recall the second step of solving equations? It is factoring. So you need to factor now. How do you factor x cubed minus 9x? So always remember that taking out the GCF is the very first step of factoring, no matter what. So there is a greatest common factor. It is x, so we're going to take that out. And now you have x times what is x cubed, x squared, and then you have minus 9. So how many answers do you think we're supposed to have in this particular problem? How many answers do you think we're supposed to have? So if you said 3, you are correct, right? Because the degree is 3 here, as you can see. The degree is 3. Alright, so now let's look at it. If you'll notice, we have not factored completely just yet, because what is this called? X squared minus 9. This is called a difference of squares. So we must factor completely before we move on to the next step. Always drop all factors. Don't lose the factors, because the factors are the way you will obtain all of your solutions. So if you get rid of one, you lose a solution. Alright, so we have x still times, how do you factor this difference of squares? Hopefully you say x plus 3, x minus 3. Alright, and if you're still a little shaky about factoring, make sure you print out that factoring guide I created for you. It's sort of like a flow chart to help you understand which direction. Notice here that we have 3 different factors, and that's good, right? Usually it coincides with the degree. Not always. Not, I would say about 95% of the time you should have, this should match up. There are some cases that don't follow this rule, but I'll explain to you at some point later, but this should always match up. Now, set each factor to 0, so x equals 0 is the solution. X plus 3 equals 0, and then x minus 3 equals 0. Then you have to solve for x. So you'll subtract 3 here and get x equals, oops, I didn't subtract from the other side, x equals negative 3, and then you will add 3 here to both sides to get x equals positive 3. But notice you have 1, 2, 3 solutions. Alright, let's try another one. We have the perimeter of a rectangle is 32 inches and the area is 60 square inches. Find the length and width of the rectangle. So this is a little bit more in depth, because you have to know, as you can see, the perimeter of a rectangle. You have to know formulas to solve this problem, and area of a rectangle. So first thing you need to do, make sure you know the formulas for the perimeter of a rectangle and the area of a rectangle. Alright, so let's go to the whiteboard. Alright, so first things first, and that is you need to write down the perimeter of a rectangle formula. So as you notice, we have a rectangle here, right? And you have, let's say this is WWLL, right? Perimeter means add up all the sides. So perimeter would be, you have 2 L's and 2 W's, right? 2L plus 2W. And the area would be L times W. Now notice that they gave us some information. Given, let me write given over here. Given that P equals what? It's actually 32 inches, right? Alright, A equals 60, right? 60 square inches. Alright, now that we know that, let's plug in what we know. So let me show you. So I know that P equals 2L plus 2W, but I also know that P equals 32. Right? So I'm going to replace the P with a 32. And I also know that A equals 60. So I have to use this information right here to figure out what is this L and what is this W. Well, you could possibly solve for one of the variables and plug it into the other equation. So yes, you can solve for one of these variables and plug it into the other equation. Let's just try something, and let's see what happens. Alright, so for example, let's solve for so we have 60 equals LW. Let's say we just solve for L. We're just playing around to see what can happen. If we solve for L, we get L equals 60 over W. Alright, can I plug this into the other equation? Let's try it. So we have 32 equals 2 times L plus 2W. Now notice here, 2L. But we just said that L equals 60 over W. So we're replacing the L. Y'all get that? Alright? We're replacing it. That was 2L right here. But L is the same thing as 60 over W. And we have to get it down so that it's just one variable. We can't find the answer to something when it's still a L and a W in the problem. Alright, so that's 32 equals 120 over W plus 2W. That looks weird. Now, what we can do, because we don't like variables in the denominator, we can get rid of that fraction. I wonder if y'all know how to get rid of that. Well, let me tell you. You can multiply everything by the LCD. You may have learned that in Math 098. Alright? So if I multiply everything times the LCD, then I get rid of that fraction there. So if I multiply W times 32, I will get 32W equals W times 120 over W will be 120 plus W times 2W will be 2W squared. Alright, where are we here? We are solving an equation, if you notice. Now we have to solve an equation. And we have to follow the steps of solving an equation. Alright, so do you recall the steps of solving an equation? The steps are, first, get everything on one side. Alright, so let me rewrite that back over. 32W equals 120 plus 2W squared. I'm going to put this on this side just because my 2 is already positive. That's the leading coefficient, is already positive. So I'm going to subtract 32W, alright, from both sides. And now I'm going to get 0 equals, I'm going to rewrite this in order, right? 2W squared minus 32W plus 120. And now we have to factor. Notice that we have a GCF here, so let's take that out. 2 times W squared minus, alright, hopefully y'all going along, 2 times what is 32W plus, alright, here we can continue to factor because we haven't factored completely. This is a trinomial, so I know it's going to be W and W, but what are factors of 60 that add up to negative 16? I don't know. Let's see. Alright, 2 times 30 is 60. 4 times 15. Alright, what about 5? What about 6 and 10? Now that sounds like a winner if we will make the 6 and the 10 negative. That way they add up to negative 16 but multiply to give me the positive 60 that I need. So you will have minus 6, W minus 6, W minus 10, and you have factored completely. Notice that now we have to set all our factors to 0, but does 2 equal 0 make sense? It does not make sense, so we throw that answer out. You could have just divided both sides by 2 to get rid of it if you wanted to, because it just doesn't make sense. So what we really want is to set W minus 6 equals 0 or W minus 10 equals 0, because the 0 equals 2 does not make sense. 0 does not equal 2. Alright? Alright, so one solution is W equals 6, and one solution is W equals 10 for the width. Now if the width was 6, what is the length? Or if the width was 10, what is the length? Now we know that the area was 60, right? 60 equals LW. And if we know that the width is 6, right? Then what would the L have to be in order for it to be 60? L would have to be 10. And vice versa. So if W equals 6, L equals 10, and if W equals 10, L equals 6, because they have to multiply to give us 60, right? But 2L plus 2W must add up to give us 32. Alright, so let me write that here. 2L plus 2W, 2 times the length, for example, let's say 10, plus 2 times 6, will that give us the 32? 6. 20 plus 12, yeah, that works. That checks out. So that's how you